Welcome back. I hope you figured out what goes in that memory latch. So let's actually look at what goes in the memory latch. So we still need stat and I-code because I-code controls everything that happens, and the status we need to report when the instruction is finally done. Now we no longer need ifun because that actually was fed into the ALU. The ALU did stuff, set condition codes, and then we computed on those condition codes to create this, what in the sequential implementation we called cond, and is going to be a field in the memory register, which is sort of the result of putting together the ALU operations, how it set the condition code, and which instruction and function that we're actually doing. And so that's all going to put some value in this CND. Now, val C and val B went through the ALU and got transformed and became val E. You might think that val A also disappeared, but it turns out that for certain instructions, and I'm going to leave it to you to remember which one, we actually need to carry that val A along later in the pipeline. So val E shows up now for the first time. Val A is still there in the register, and we haven't done the write back yet, so we certainly still need dest-D and dest-M. We can go through the exact same exercise to figure out what we need in the write back stage. So just like before, we need the status, we need the I-code. We still need val E because that might get written back into a register. Now, instead of val A, what we really need is what did we get out of memory potentially, which is going to show up in val M. And so we're going to take val E, val M, dest-D, dest-M, and those are going to get routed back to the register file to help us decide what we're actually going to write back in that write back stage. Now, there's one last thing that we're going to do to this picture to make it easier for us to talk about what's happening in the pipelined implementation. In the sequential implementation, we just named all the signals and that told us what was going on. But we now have signals that have the same name in different stages. And what that's going to correspond to are different instructions, right? So there might be one instruction that's in the execute phase, a completely different instruction in the decode phase. And we want to be able to talk about the I-code for those instructions separately. So what we'll do is we're going to preface the signal names with the letter of the stage. So for example, the values that are coming out of the decode register will be prefaced with a capital D. So dstat is the value coming out of the decode register for the stat field. mstat is that value coming out of the memory register. Okay, so we're going to name all the signals by prefacing them with the letter of the stage. Now, something you might not have thought about, we're actually going to preface another set of signals with a small letter corresponding to the phase. And the difference is going to be whether they're the value coming out of the register or they're the value that's flowed through all the logic and is about to go into the next register. So if we look at that mstat field, what that means is that we took the status coming out of the memory register, because it's prefaced with an M, but it went through some logic that checked what happened in the memory in this memory phase, and it might change that value. And so you can think of mstat is the value that's about to be written into the next register. So from a pipeline register, we get the signal capital M name. We go through some logic, and what we call the thing that we're about to latch into the next register is the little m, or the lowercase letter of the register stage. And if you look at this picture in a little more depth, or look at the book, you'll see how the signals have a name when they come out of the register and a different name when they go into the new register. Okay? So this is sort of a somewhat simplified version of the pipelined y86. And the reason that we want to understand it is so that as we investigate this more deeply, we're going to discover that pipelining introduces some problems. And our job is to understand what those problems are and how do we fix them. And that's where we'll be going next.